Welcome back. If you are back, if you're not there, I can't really tell. It doesn't really bother me a huge amount since I get paid anyway. Although I'm not being paid. Oh, that could have gone better. Right, writing games with C# and XNA. I'm Rob Miles. I'm still here. Last time we actually managed to get some stuff in. Go on, change to the next slide. Go on, I dare you. Oh, look at that. Drawing text. Now, we're actually getting to the point now where we're starting to actually put text on the screen. We can get these SpriteFont resources and we can link them to a particular font so we know what to actually draw. We can create a variable in our game to hold the font resource, and we can load this resource into the game variables in the program. So we've got all that. We know how the game works. We actually get the stuff in, and now we're going to use the font to actually draw some text. So we've done about 2/3 of the work. We've found the font, we've put it in the content management pipeline at the start. We've then fetched that font design, that piece of content, and brought it into our program as a resource, and now we're actually going to use that font to draw some text on the screen. We've done our drawing in the draw method, and that's exactly as it should be, because that's what the draw method is for, the draw method being the part of our XNA game that actually does the drawing. Now we're going to start using our SpriteFont, this thing we fetched from the content, to actually draw some text. Now before we do that, we have to spend some time just looking at how games, consoles and computers actually do this kind of thing. And to do that, here we go. Now, if you look at a computer, if you take a computer to bits, actually, no, don't do this. Take my word for it. They're really hard to put together again. But even if you hit them very hard with a hammer, they don't always work afterwards. But if you did take a computer to bits, this is a whatever, then you'd find that the actual display it is handled by a special piece of hardware, the graphics hardware, which does the actual drawing of the display, and that's separate from the actual game program. Now, XNA works the same way as this. Xbox 360s work the same way as this. Windows PCs do it too. The idea is that you effectively want to separate off the job of making the display update from the job of making the game program run. And so the game sends instructions to the graphics hardware, and the graphics hardware goes okie dokie, and it does them. Okay, and this is how games work, and this is how games have been working for quite a long time now. If you think about actually telling someone what to do, if you had a butler who could draw, which would be nice, you wouldn't sort of tell him what to do. It's nice if you can give him a list of things to draw. You know, Jeeves, yes sir, if you could just draw me a square over there, yes sir, followed by a circle, yes sir, followed by a line, yes sir, and now go off and do all that. Yes sir. Then Jeeves could go off and draw the picture, and then you could get on with the more important stuff like drinking gin and reading the Sunday newspapers, whatever you want to do. Actually, I don't do that. Honestly, I don't. Not the gin bit anyway. And so you could do something else while the screen was being drawn, and then you could catch your butler later when he's finished doing that and get him to draw the next bit. Now this is sort of like a batching process. The guy with the pile of packages could have put all those in one big box if we'd wanted to sort of get them all to the same place, and then brought them instead of lots of little ones. And so the computer and the graphics hardware work in just the same way. It's best if I can batch up all my commands to the graphics hardware to say, okay, here's a bunch of stuff I want you to do, now just go off and do that, and then when you finish that, catch up with me later and I'll give you some more commands to do. Turns out that XNA actually provides a thing which is called the sprite batch sort of type, and this does it all. It's great. I like XNA because the names of everything reflect pretty much exactly what they're going to do for you. I'm going to batch some sprites up, so I'm going to use the sprite batch command to do it. A sprite, by the way, in case you haven't heard this word, it's not a pixie with wings. It would be nice if it was, although it could be. If you write a pixie with wings fighting game, then your sprites could be sprites, which is kind of weird, but there you go. A sprite, as far as we're concerned, though, is a drawable item on the display. If I'm playing a shooting game, a sprite would be a bullet. If it's a driving game, a sprite might be a car or a tree that's whizzing past the windscreen or anything like that. So a sprite is a single thing you want to draw on the screen, and we get these things and we have a need to draw them, and to draw them we have to batch up all the commands to draw them into a single lump. The actual sprite batch itself, now we saw this, it was made in the load content method. We saw this last time when we actually saw that the line before the one where we load our content is where we make a new sprite batch, and we only need one of these because it'll do all the work for us, and it's connected to the graphics device in our computer or our Xbox. So at the very start of load content we have a game variable called sprite batch, which is set to a brand new shiny sprite batch instance which is tied to the graphics device. And once we've got this is basically our graphical butler. This is the thing which will do all our drawing for us. We'll tell it to start drawing, a bunch of stuff to draw, and then that's it. Now you can go ahead and actually get on with the work. In fact, if you look at the code, that's exactly how it works. We have a begin method which says, okay Jeeves, I'm beginning to tell you stuff to draw. And Jeeves gets a new piece of paper and a pen, and you say, okay, I want a square up there, yes sir, and a circle there, yes sir, and a picture of my dog there, yes sir. And that's it for now. Go off and do that. Okie dokie. So Jeeves finishes his list, goes off, does the drawing, rushes back at some later time, and you give him some more commands. And so begin actually starts off the drawing process, and end is where you finish it. And you have to have these two things in pairs. You have to start the drawing and end the drawing. It's important that you actually do that. Okay. And so what happens is that we actually, to recap, which doesn't mean putting another hat on. Oh, these are so funny. Why aren't you writing them down? You aren't writing them down, are you? That'd be worrying. Sprite batch is used to batch up and manage commands for graphics hardware, and we keep a copy, a variable of this type. Now this is a bit confusing because sprite batch is the type, okay, and then sprite batch with a little s is the actual variable, okay. So sprite batch is like the master class. It's the thing we want, and then an instance of that, the actual sprite batch we're using, has a little s. I'm not particularly keen. This is one part of XNA where I think they could have named it a bit better because it's a little bit confusing, but as far as you're concerned, we have to have a begin and an end method which we call to start the drawing, and everything else just comes out in the wash. So don't worry too much about it. Just remember that to do drawing of stuff on the screen, you do it in the draw method, and you use this wonderful sprite batch thing to do the drawing for you. Okay, and it's as simple as that. Once I've got my sprite batch, I can tell it to do stuff. And so there's my begin that says herein beginneth my commands to the sprite batch, and then I've got a drawString method which I can call to draw a string. Another good name. The name reflects exactly what it does. It's given a font, in other words the shape and design of the characters to use. It's given a string which actually tells it the text which needs to be drawn. It's given a position on the screen, which is this vector2 thing with the value of 0, of which more in a moment or two, and the color of the text to draw as well, which in this case is white. Okay, so we have the font, we have the string to draw, we have the place to put it, and we have the color to use. And since all we're doing is this one text drawing command, we can then end the sprite batch, and at that point that's when the magic happens. That's when the butler rushes off and puts the pictures on the screen. That's how it all works. So if I now actually drop out of my program and I drift up here, this is what we did last time. Last time I have a font called message font, which I fetched into my content manager. Load content, there's the line that makes the sprite batch, okay, and there's the line that fetches the font. I then print a little message to the programmer. Remember, the user doesn't see this. The console is a secret message method where I can send little bits of text to the programmer. The game player never sees this. And then what I want to do now is drift down to my draw method down here, and I'm going to go in here and I'm going to tell my sprite batch to start beginning the drawing. And this is a trick, this is a tip worth bearing in mind. I can also put the end call in, and then I can put my code in the middle. Now this is kind of cunning because I'm not going to forget now. If you put the begin and the end in together and then go back and fill in the bit in the middle, you won't tend to forget to put the end on. If you forget to put the end on, then bad things will happen in that your program won't work, which is about the baddest thing that you can have happen. So I'm going to go, dear Mr. Sprite Batch, can you please draw me a string? and can you use the font that I've carefully fetched for you, and can you give me the important message hello world, which apparently, according to programming law, is the first message that your program must print. And I want to put it at this weirdly named vector, oh gosh, Robert can't type today, vector 2.0, or which more, that sounds great, it's a good name for sort of like a spacecraft location, and which a bit more later. And so I'll put it in location 0, and we'll do it in color.white. Okay, now all this stuff is flying up, and it's really impressive to watch these IntelliSense things appear. The computer's guessing what I might want to type, and then giving me the option to just add that text by pressing space. It might seem a bit confusing at first, but it's trying to help. Really it is, even though it might look a bit confusing. Having given the font to draw, the text I want to see, the place on the screen to put it, and the color to use, I'm now in business. I can end with that call of drawString, and at that point I've got all I need to draw some text on the screen. Start the drawing, I'm drawing a string, end the drawing. Press the run button, and it says hello world in monstrous text. Isn't that good? That's really impressive. If I go back to my presentation screenshot, that's a really weedy hello world. That's about 12 or 10 or so. Whereas if we take a look at my program, which I'll stop so we can take a look at the bits that make it go. Stop please, thank you. Then in here I've asked for a size of 50, which is a much more macho, sort of a bigger size. 50 is a good size for heading stuff, and 10 or 15 or so is very good for a word processor, but not quite so good for games. This is the place where you can control what size text you get. I mean, if I make this 100, then now we'll get a hello world which is so big that it fills the entire screen. Look at that. So again, you can do big text, you can do small text. It's all down to what the needs of the game are at any particular point. But I'll stop that, and we'll go back to the presentation, which I can do like that, and then we can move on to the next bit. Now this is the next bit that we need to know. It's all very well putting text on the screen. It's kind of useful if you can control whereabouts it actually gets placed on the screen. And it turns out that as far as XNA games are concerned, we position things using X and Y values. This is very much like drawing graphs, with one important difference, which is that if you draw a graph, then the 0, 0 thing tends to be the bottom left-hand corner of the screen. If you're drawing a computer game, then the 0, 0 position is the top left-hand corner. So the origin for a game is top left. So 0, 0 is here. In a game, if I make X bigger, my sprite moves across the screen to the right, and if I make Y bigger, the sprite moves down the screen towards the bottom. If you make a brand new empty XNA game, then it'll be 800 pixels high and 800 pixels wide and 600 pixels high. That's the standard screen size that XNA thinks you're going to use. You can change that if you want later. Each of these units is called a pixel, which is basically the size of one dot on the screen. I think pixel is short for picture element or picture cell, which is nice. But as far as we're concerned, it means that if I put something at 0, 0, it's top left hand corner, and that's actually exactly what we see. Okay, so thing is, 0, 0's all very well, but a bit boring really. I want to put the screen, the text in other places on the screen as well. So I have to use this thing called a vector. Now a vector is a pair of X and Y values that specify how far across to move and how far down to move. Look at this vector, it says go 3 across and 1 down, and I've got an X value and a Y value that reflect that. It actually gives a direction, I guess, a vector, because it tells you if you're at 0, 0 and you are facing the destination point, that will give you the direction and distance to travel. Okay, as far as we're concerned, we're not really doing a distance type movement type direction type thing. We're just saying where the text needs to be, and what we can do in our game is we can sort of change whereabouts the text appears. Now as you can see here, there's a special built-in vector called go nowhere although they've called it 0, which is a little bit shorter, and so That's why when I did my hello world it came up top left hand corner. But if I want to, I can make a new game data variable which I could call text position, and that could be somewhere else on the screen. So I'll store this along with my font, and if I want to during the game I can change where the text is positioned and make it appear to move around the screen. If you want to sort of do one of those scrolling titles like they have at the end of TV shows, then moving the text position around to do that is exactly what you would do. That's how you would actually get the change and get the thing to behave. So my update here doesn't actually do that. Update just puts the text at 200 across and 100 down, but we could make the text anywhere we like, and we'll be doing that kind of thing a little bit later on. So all I have to do now is get my text on the screen at the new position. So rather than giving it this 0 place, I give it a new position to put itself, and then I'm in business. And so what I can do now is take my program, which I go back to here. Let's put the font size back to 50, otherwise it's going to be huge, far too big to contemplate. And I'm going to go in here and I'm going to drift up to my game variables. Where are they? They're up here. Okay. And I'm going to make a vector 2, and I'm going to call it text position. And that now I've now got a variable in my game that tells me where the text has got to be drawn. What I now do is go into my update method and add the bit of code that sets this up. So now I go text position.x equals 200 and text position dot y equals 100. So now I'm saying go 200 across and 100 down, and then if I go into here, rather than drawing at the 0 position, I'm going to say use this text position I've carefully created. Okay, so if my theory is right, and of course my theories are always right, I'm never wrong except when I make a mistake, then we should have the text across a bit and down a bit. And so run the program, and bang, it's now sort of towards the middle of the screen. It's gone, that is 200 pixels across and 400 and 100 pixels down, which is about right. It's about twice as far across as it is down the screen, because pixels are supposed to be square. Okay, so right, we can now position our text anywhere on the screen, and even maybe move it around a little bit later. And so placing text, yep, we can do that. So what we learned today, quite nice. We have this SpriteBatch thing, which is effectively our drawing butler, which can take drawing commands and use them to put pictures on the screen. And we know that we give him a list of stuff to do, because that's how butlers like to be. I know a lot about butlers. Never going to have a butler in my life, but I know a lot about them. As far as we're concerned, the text is drawn using this SpriteFont thing we loaded last time, and we can place it on the screen using this thing called a vector 2, which gives us how far across and how far down the screen we want to move things, and if we modify those, we can place the text anywhere we like. Okay, so a bit of true and false, and then we can all go on and have our cup of tea. Okay, a SpriteBatch is used to batch together drawing operations. True or false? Yep, I'm going with that being true, because that's exactly what it does. If you translate SpriteBatch to butler who can draw very well and likes being given lists of things to do, then that's pretty much where you want to be. Okay, so the begin method must be called, no, it's gone red. You don't do that. You call one begin, at which point we start doing the drawing, and then when you've finished everything, you call the end. So we don't need to begin everything. If I was doing 20 draw operations, I'd do them after the begin, then I call the end. The whole basis of the batching is you sort of give it a start, a bunch of stuff to do, and give it an end, and then you're done. Okay, so drawing is performed in the update method. True or false? Scratch his chin thoughtfully. That's actually rubbish, because update is where you update the game. Drawing is where you draw the draw methods, where you do the drawing, and the two are distinct and separate. And so you mustn't draw in update or update in draw. That's bad karma and will cause horrible things to happen to you later in life. Trust me. Okay, a vector contains x and w values. W, wrong, x and y. W is the count of wombats in a program that counts wombats, and we're not counting wombats, we don't have a W, therefore vector 2 contains x and y. A game can only contain one vector. Well, it can contain as many vectors as you put there. That's obviously rubbish. So as far as we're concerned, lots of red this time. One green and lots of red, but there you go. Right, so thank you for that. Remember, source files and more screencasts and bits and pieces at verysillygames.com/screencasts. My name is still Rob Miles. It's been Rob Miles for a very long time now. And anywho, not relevant to this bit, but thank you very much for paying attention if you have. And I'll see you next time. Well, I won't, but if you come along next time, you'll see bits of what I've done. Thank you.